All right, let's do this. We're going to try and cover, just about 13.8 billion years of history in the next 5 minutes. Yeah, you heard that right. Let's dive in.
I mean, this is it, isn't it? This is the ultimate question. It's the one that sits at the very heart of, well, literally everything.
So, where do we even start? Our story begins right at the beginning, the very first second of existence.
Okay, so first things first, we gotta get one thing straight about the Big Bang. It wasn't some kind of explosion in space, like a giant firework. No. Think of it more like the rapid expansion of space itself. Everything, and I mean everything we know, time, matter, energy, it all kicks off right here, 13.8 billion years ago. And when I say rapid, I really, really mean it. It's almost impossible to wrap your head around how fast this was. In a fraction of a second, so tiny you can't even imagine it, the universe just ballooned. It expanded exponentially. We call this wild phase cosmic inflation, and it basically set the stage for the entire cosmic play that followed. So you've got this incredibly hot, super dense beginning. From there, the universe starts to expand. And this is the really key part. It starts to cool down. And that cooling process, that's what's going to allow the very first light to finally break free and shine. Okay, let's just take a quick pause here for a roadmap just to put all of this into perspective. We're starting way back at the beginning, but just look at how long it takes to even get to the first stars, or our own planet Earth. And us, humans, we're just this tiny little blip at the very, very end. It's kind of humbling, right? Keep that scale in your head as we keep going. So, how did that first light actually appear? Well, for the first few minutes, the universe was just this chaotic hot soup of particles. Imagine a fog so thick that light couldn't go anywhere, it was just trapped. But after about 380,000 years of cooling down, things started to change. The universe got cool enough for electrons and nuclei to team up and form the first atoms. And just like that, light was finally free to travel. And here's the coolest part. That first flash of light, it didn't just disappear. It's still out there, traveling through space. Over billions of years, the expansion of the universe has stretched it out into microwaves. Today, we call it the cosmic microwave background, and it is quite literally the afterglow of creation. It is the oldest light that we can possibly see. Just think about that. Okay, so light can finally travel. The universe is transparent, but it's still pretty dark out there. There are no stars yet. So our next chapter is all about how those first cosmic forges finally got lit. For millions and millions of years, the universe was basically just these huge, drifting clouds of hydrogen and helium gas. But there was this one patient, relentless force at work the whole time: gravity. Ever so slowly, it started pulling these clouds together, gathering up the raw material and planting the seeds for what would become the very first stars. And then, somewhere between 100 and 200 million years after the Big Bang, it happened. These clumps of gas got so dense and so hot that they ignited. Boom! Nuclear fusion kicks in, and the first stars just roar to life. But these weren't just pretty lights. Oh no, they were cosmic factories. Inside these nuclear furnaces, they started forging hydrogen into heavier elements. And when these massive stars eventually died in these incredible explosions, supernovas, they scattered all those new elements, like carbon, oxygen, and iron, all across space. And this is the part that connects it all back to you. The very atoms that make up your body, the planet you're standing on, the air you're breathing right now, all of it was forged in the heart of an exploding star. It's not just a poetic saying, we are quite literally made of stardust. Okay, so the building blocks are there. We've got the elements. Now let's zoom in a bit from this massive cosmic scale and try to find our own little address in the universe. So, these stars weren't just lonely wanderers. That old friend gravity was still at it, pulling them together into these truly immense structures that we call galaxies. And over billions of years, billions of these galaxies formed, including our very own home, the Milky Way. So let's fast forward to about 4.6 billion years ago. In a pretty quiet, unassuming spiral arm of the Milky Way, our own local story finally begins. A cloud of gas and dust, all that stuff enriched by those earlier star explosions, it starts to collapse in on itself. Most of that material goes right to the center and boom, our sun is born. The leftover bits and pieces, well, that stuff swirled around and eventually formed the planets, including our home, Earth.
And on this brand new planet, something truly incredible happened. Life, simple life at first, emerged in the oceans. But it's really humbling to remember just how recently we, as humans, arrived on the scene. We only appeared about 300,000 years ago. In the grand scheme of things, that is barely a blink of an eye.
Okay, so that pretty much brings our history up to the present day. But the story of the universe is far from over. In fact, a much more recent discovery has thrown a huge wrench in the works, revealing a deep and pretty profound mystery. So for a long time, scientists figured the expansion of the universe must be slowing down, right? I mean, gravity is pulling everything back together. Made sense. But then, in 1998, everything we thought we knew got turned on its head. Scientists found something absolutely shocking. The expansion isn't slowing down, it's speeding up. Something out there is actively pushing everything apart. So, what is this mysterious something? Well, scientists gave it a name, dark energy. And here's the real kicker. Just look at this breakdown of the universe. Everything we can see, every star, every galaxy, every planet, you, me, all of it, makes up only 5% of the universe. Just 5%. The rest is completely invisible. About 27% is something called dark matter, and a whopping 68% is this mysterious dark energy. Let that sink in. We live in a universe where we can't see or understand 95% of what's out there.
You know, this whole discovery, it forces us to ask that final, ultimate question. If this is how it all began, how is it all going to end?
Well, there are a few leading theories on the table. One is the Big Crunch, where gravity might eventually win out. But with expansion speeding up, that seems pretty unlikely. Then there's the Big Rip, which is, yeah, as dramatic as it sounds. Dark energy gets so powerful it literally tears everything apart. But the one that seems most likely right now, it's called heat death. The universe just keeps expanding and cooling, until eventually the very last star flickers out and everything just fades to black.
So, when you take a step back from this incredible journey, we went from an impossibly small, hot, dense point
To a universe that blossomed into billions upon billions of galaxies, filled with countless stars and planets.
all of it leading to us. Here, now. Conscious beings, able to look up at the sky and back in time and ask, how did this all happen? The story of the universe really is our story. And we're the part of the universe that gets to wonder about it all.